Hello, Algebra 1. Welcome to the Lesson 7.2 videos on multiplying polynomials. So in the last lesson, we added and subtracted our polynomials. Now we're going to multiply. Now we've done some multiplying polynomials already when we do distribution, right? So now it's just we're going to deal with some x's involving exponents and what do we do and all that fun stuff. Now I do want to talk about one thing when it comes to multiplying, right? And it's about the exponents, right? So if I have x times x squared, right? Because this is going to happen a lot. When you have like bases, so when I say like bases, I mean the x and the x are the bases. What you do is you add the exponents. So when we added and subtracted polynomials, we never changed the exponents, right? We just found the like terms which had the same degree of the same exponent and combined those coefficients. Well, here, this x has a exponent of 1. This x has an exponent of 2. You're going to write this as x to the 1 plus 2 power. You're going to add those exponents. And this has actually become x to the third. So today, your exponents are going to change. This is something special that happens when you multiply, right? Not when you add or subtract polynomials, but when you multiply polynomials. So let's get right to it. All right, so what is the product of negative 4x to the third and x squared plus 3x minus 4. So again, all year long, we've used the distributive property. We know how to do that, right? So it works the exact same way. So we're going to do negative 4x to the third, and we're going to multiply it by x squared plus 3x minus 4. So again, this negative 4x to the third goes once, twice, 3 times to each term of this trinomial. We have a monomial being multiplied with a trinomial. So down here, I'm going to do it very slowly. So we're going to do negative 4x to the third times x squared. We're going to do negative 4x to the third times 3x. And we're going to do negative 4x to the third times negative 4. So I've written out each individual multiplication through the distribution down here. Okay. So this is negative 4x cubed times 1x squared. Negative 4 times 1 is negative 4, and you add the exponents. X to the third times x to the second is x to the fifth. 3 plus 2. Negative 4 times 3 is negative 12, so this is a minus 12. X to the third times x to the first, you add the exponents, that becomes x to the fourth. And then negative 4 times negative 4 is positive 16. And the x to the third is the only variable, so you leave it alone, x to the third. And this is your simplified polynomial. Again, I have some space between them. There should be no space, right? Negative 4x to the fifth minus 12x to the fourth plus 3x cubed. Okay? All right, now what happens when we get away from just multiplying or distributing a monomial, right? What if we distribute a binomial or a trinomial? What happens? Well, let's keep going. So how is multiplying binomials like multiplying two-digit numbers? So again, understand binomial is 2 terms, 2-digit numbers, 2 numbers, right? So we're going to multiply the expression 15 times 18 and compare it to multiplying x plus 5 times x plus 8, right? This is a binomial, x plus 5. This is a binomial, x plus 8. Well, let's work with the 15 times 18, right? So if you have any little brothers and sisters, I think that in their elementary classes, they're learning how to multiply two-digit numbers like this. They're breaking 15 up into tens and ones. So 15 is 10 plus 5, and 18 is 10 plus 8. So they're breaking up their numbers just like this. So when we do this multiplication, we need to multiply this 10 by that 10 and this 10 by that 8. We then need to multiply this 5 by that 10 and this 5 by that 8. Everything in the first parenthesis gets multiplied with everything in the second parenthesis. Notice the only 2 things that don't get multiplied are the 10 and the 5 and the 10 and the 8. And that's because there's addition between them. It's not multiplication. All right, so again, down here going slowly, right? So we're going to multiply the first 10 by the 10 plus 8. And we're going to multiply the 5 by the 10 plus 8, right? So it's just 2 separate distributions, okay? So when you do 10 times 10 and 10 times 8, you get 100 plus 80. When you do 5 times 10 and 5 times 8, you get 50 plus 40. And you would just add those as they are, right? 100, 180, 230, 270. Well, now you can do what's called the table method as well, and I'll do the table method in purple. So in the table method, what you do is you create a grid. It has 3 columns and 3 rows, just like tic-tac-toe, yeah? So this space stays blank. Up top, you put one of your parentheses. On the left side, you put one of your parentheses. It doesn't matter, right? So I'll put the 10 and the 5 on the left-hand side from that parenthesis, and I'll put the 10 and the 8 above from this parenthesis. And now, this is just a straight multiplication table. You just take your fingers and you say, okay, this box is 10 times 10, which is 100. This box is 8 times 10, which is 80. This box down here is 5 times 10, which is 50. This box right here is 8 times 5, which is 40. And again, you get the same 4 numbers you got over here. 100 plus 80 plus 50 plus 40. And again, you get 270. So when we do the binomials, it's going to be the exact same thing. So now we're going to do the exact same thing with our 2 binomials. X plus 5 times x plus 8. Again, the first x gets multiplied to everything in the second parenthesis. This plus 5 gets multiplied to everything in the second parenthesis. So we just have x times x plus 8 plus 5 times x plus 8. When you distribute the x to those two, x times x is x squared. Remember, you add their exponents. X times 8 is 8x. In the second parenthesis, distribute the 5. 5 times x is 5x, and 5 times 8 is 40. Remember, make sure you multiply. A lot of people would put 13, right, because they think it's addition, because they see the plus 5 and the plus 8. It's multiplication. And now we just combine the like terms. There's only one squared term, so that's x squared. Then we have 2 x terms. 8 and 5 make 13. Just do as it says. Notice the exponent doesn't change. And then the 40 is the only constant term. Now again, we can set up our tic-tac-toe grid over here, just like we did for the 2-digit numbers. Again, tic-tac-toe, 2 lines, 2 rows. This table stays empty. I'm going to put the x and the 5 here, the x and the 8 there. And again, you multiply down and across. X times x is x squared. X times 8 is 8x. Multiply down and across. X times 5 is 5x. Down and across. 5 times 8 is 40. So now we just do x squared plus 8x plus 5x plus 40. Right? You write these 4 terms horizontally, and you combine. Right? We have an x squared. We have an 8x and a 5x, which is 13x, and then we have the plus 40. Same exact answer, no matter if you do it horizontally or in the table. All right, so now aside from a table, another visual to represent multiplying binomials is using a rectangle, right? So it says, what is the area of this green rectangle? Well, we have to know that area of a rectangle is either base times height or length times width, whatever you want to do, okay? So in this picture, what these sides represent are the base and height. This is your base. This is your height. So a couple ways to think about this, right? Number one, we can think of this like a table, and we can do, okay, this side is 2x long, and this side is x long, right? X down here. So the area of this rectangle would be 2x times x. Well, 2x times x is 2x squared. This rectangle has a height or a length or width of 2x and a width of 3. So now we're doing 2x times 3. 2x times 3 is 6x. Down here, this rectangle has a height of 1 and a base of x. 1 times x is just x, or 1x. And this one has a height of 3 and a base of height of 1 and a base of 3. 1 times 3 is just 3. So visually, the area of this rectangle is 2x squared plus 6x plus x plus 3. It's the same as the table we did up above. And you would combine your middle terms. The 2x squared stays the same. Your middle terms are at 6x and a 1x. That's 7x. And then the 3 comes down. Now again, if you want to do it horizontally, you can make this 2x plus 1. And you make this x plus 3. And you can do it using the distribution method. This 2x goes to the x and the 3. Now again, for the next time, I'm going to write it like this: 2x times x plus 3. In the future, I will not put this step. I'll skip it. And then the 1 times x plus 3. And now again, we distribute the 2x. 2x times x is 2x squared. Remember, x times x, add the exponents. 2x times 3 is positive 6x. The x just comes. Over here, distribute the 1 to the x and 3. 1 times x is just 1x. 1 times 3 is not 4. You're not adding, you're multiplying. 1 times 3 stays 3. Again, you have your 2x squared, your 6x and your 1x becomes 7x, and you have your plus 3. Same answer as over there. All right, last but not least, let's do one more of these distribution problems. Okay, it says, how can you use the distributive property to write as a polynomial, right? So again, this is the idea of distributing the first binomial to each term in the second, right? This is what we're doing here. I've done it for the last 2 problems. Distributing the first binomial to each term in the second binomial. So we'll do that here. So 2x plus 4 times x minus 5. Now again, here I'm not going to write down that step I said I was going to leave out. So we're going to do 2x times x and 2x times negative 5. 2x times x is 2x squared. X times x is x squared. 2x times negative 5, 2 times negative 5 is negative 10, and the x comes along. And now we do the 4 to both terms in the second parenthesis. Positive 4 times x is positive 4x. Positive 4 times negative 5 is negative 20. Again, you multiply. You don't add, you don't combine, you multiply. So the 2x squared gets written down because it's the only squared term. Combine your negative 10x and your positive 4x. It's negative 10 and positive 4. Use Desmos. That's a negative 6x. And then bring down the negative 20. I should say minus 20. There you go. Now again, if tables is the way you want to go, I'm fine. Play your tic-tac-toe game. This stays empty. 2x, 4x minus 5. Notice how I put the minus 5 in there. That's important, right? In the previous problems, we didn't have negatives. So if it's a negative, you have to put the negative with it, right? So again, multiply 2x times x is 2x squared. 2x times negative 5 is negative 10x. So now you have these negative signs, right? So be careful, okay? 4 times x is 4x. And negative 5 times positive 4 is negative 20. And then in this table here, the only items that combine are the x terms. So your 2x squared gets written first. 4x and negative 10x is negative 6x. And then negative 20 comes down as well. So again, I don't care how you want to do your multiplication. No matter which way you do it, you should get the same answer. All right, so that's video 1. We got more multiplication coming up in video 2.